Okay, so polynomial identities, if you remember from geometry about identities, and maybe talked about it in Algebra 1 as well, but a mathematical statement that equates two polynomial expressions as an identity if one side can be transformed into the other side by using mathematical operations. In other words, in identity, both sides are equal. Like I can multiply this right side out of difference of squares and end up with the left side. That's called an identity. So the first one, difference of squares, you probably recognize this. It's how we factor pretty quickly with something like this. So first of all, has to be different, so I have to have subtraction, and then I have perfect squares. So if it's 49x squared minus 121y to the fourth, then I want to think about what the square root would be because of each of these terms, because I know we're going to have exactly the same thing in these parentheses, but 1 minus 1 plus because I don't have a middle term. So I only have two terms. They're both perfect squares, have a subtraction sign in the middle, so we can go with this. The square root of 49 is 7, and the square root of x squared is x. The square root of 121 is 11. The square root of y to the fourth is y squared. Remember, I divide my exponents by 2 when I'm trying to figure out the square root of those. So I have 7x minus 11y squared and 7x plus 11y squared. All right, the square of a sum, which is perfect square trinomial, that's a quick way to multiply it out. So we're kind of looking for shortcuts here. Also, like going the other way with this, if I see factors like this, I know that it's 49x squared minus 121y to the fourth because the outside and the inside are going to add to be 0. So you can check that out. All right, square of a sum, we're going to multiply that out. So notice it means a plus b times a plus b, but the shortcut is square the first term, multiply the two terms together and double it, square the last term. So we want to try that. So let's go with 25a plus, let's go 4b to the third, and we're going to square that. All right, so 25a, and then we're going to square the whole thing. So I have 25a squared plus 2 times both terms, 25a, 4b cubed, plus the last term squared. All right, and then we'll clean this up and we'll be finished. We didn't even have to multiply stuff out, like FOIL things. All right, so 625, 25 times 25, a squared, plus 2 times 25 times 4. Well, I know 25 times 4 is 100. So 200 ab to the third plus, and then we're going to square both those terms. Remember to square the number. So 16 b to the 6, because when we have a power to a power, we multiply our exponents. All right, so there's expanded form of the square of a sum. All right, difference of cubes. All right, difference of cubes, kind of like difference of squares, but these are both cubed, and this is what it will factor into. All right, so let's go 8x cubed minus 27y to the ninth. All right, so I want to think about what the cube root of these is. The cube root of 8 is 2, and then the cube root of x cubed is just x. The cube root of 27 is 3, and then I'm going to divide my exponent by 3, so that makes that a 3 cubed. So this is a and this is b when I plug into this formula. So I have 2x minus 3y cubed, and then continuing on with the formula, a squared, which would be 2x times 2x, which would be 4x squared. Then multiplying a times b together. So plus 6xy cubed, and then 3y cubed times 3y cubed, would be 9y to the 6th. Or you can think about it as 3y cubed squared. Right, so that's it. This won't factor. You can put it in quadratic formula. We're going to get imaginary numbers from that. All right, sum of cubes, this formula is very similar to what we were just looking at, except the sign in the middle is positive. And so notice this is negative, everything's positive. This starts positive, the first sign's negative, the last sign's positive. All right, so let's go, how about 125 x cubed, I don't know why I put parentheses on that, plus, let's go 1. So 125, the cube root of 125 is 5. Cube root of 1 is 1. So 5x times 5x, or sorry, we just want 5x. So 5x plus 1. And then we'll start with the squaring. So 5x squared is 25x squared. 5x times 5x plus 5x times 1. So remember this was a and b. So it's just 5x plus 1 squared. So that's it for that one. All right, expanding the power of a binomial. This is like a huge time saver. We're going to use Pascal's triangle because from Pascal's triangle, we can get the coefficients of each term of the expanded form. So Pascal's triangle, all the numbers on the outside of this triangle are 1s. The numbers in the middle are found by adding the 2 numbers above. So 1 plus 1, 2. 2 plus 1 is 3. Sorry, 1 plus 2 is 3. 2 plus 1 is 3. Numbers on the outsides are 1. I add, I get 4, 6, and 4. So numbers on the outsides are 1. I add 1 and 4. I get 5. I add 4 and 6, I get 10. 4 and 6 and 4, I get 10. 4 and 1, I get 5. So you may see the pattern already, and we could keep going. But this is x plus y to the 0 power, x plus y to the first power, x plus y squared, x plus y to the third, x plus y to the fourth, and x plus y to the fifth. I'm going to move this 1 down just a little bit. Okay. All right, so like I said, these are coefficients. We know, like this row is x squared plus 2xy plus y squared. And so you see the coefficients are 1, 2, 1. Because there's nothing in front. And there's 1, 2, 1. So if I want x plus y to the fourth, I go to the 1, 2, 3, 4, 5, fifth row because we start at 0 power. And these are my coefficients. So I'm just going to show you what I like to do. I write the coefficients down and leave some space so I can fill in. All right, then I start with the first variable to the power that I'm given, so x to the fourth, and then in each of these slots I'm going to go down 1 in power until I get x to the first. The last one would be x to the 0, so I don't write anything down. And then I take the last term, and you can start at the back and move to the left. I just usually start at the front, so I'm going to start with y to the 0, y to the first, y squared, y to the third, y to the fourth. So all of these variables, their exponents have to add to be 4, so that's a quick check. And they do. I start with the first variable, go down, second variable, start at 0 and go up. Right? And that's the binomial expansion. Way faster than having to do this. Multiply it out that many times. All right, let's try one more. Let's do 2x squared plus 3y, and let's go to the fifth this time since I have that row. That'd be this one. All right, so let's start it by 1 plus 5 plus 10 plus 10 plus 5 plus 1. All right. Now we're going to fill in. All right. So I'm going to start with 2x squared. So 2x squared to the 5th, 2x squared to the 4th, 2x squared to the 3rd, 2x squared to the 2nd, 2x squared to the 1st, and then 2x squared to the 0. We don't need to write that. All right, now we're going to come back with the 3y. So 3y to the 0, I'm not going to write that. All right, so 3y to the 1st, 3y squared, 3y to the 3rd, 3y to the 4th, 3y to the 5th. All right, now we're going to clean up. So 2 to the 5th, so I have 2x squared multiplied 5 times by itself. So 2 times 2 times 2 times 2 times 2. So that's 8 times 4, so it's 32. X to the power we multiply, so x to the 10th, plus 5 times 16x to the 8th, times 3y. We'll come back and clean that up in a second. So I have 2 to the 4th, x to the 2 times 4 would be 8. Oh, I wrote a 6. Okay. And then 2 to the 4th is 16. All right, let's go to the next one. 10 times 8x to the 6th, and then 9y squared. When I square that, oops, not that way. 9y squared, there we go. 3y times 3y would be 9y squared, plus 10 times 4x to the 4th, times 27y to the 3rd, plus 5 times 2x squared times 81y to the 4th, so it's 3y to the 4th, plus 3 to the 5th, so it'd be 81 times 3, so 243 y to the 5th. All right, so we have a few things to clean up, but that's way faster. I know that doesn't seem super fast, but it's way faster than multiplying all those out 5 times. So 15 times 16, that looks like, or 16 times 5, that's 80, times 3, 240. So plus 240x to the 8th, plus 8 times 9 is 72, times 10 is 720, x to the 6th, y squared, plus 4 times 27, 108, so 1080, x to the 4th, y to the 3rd, plus 810, x squared, y to the 4th, plus 243, y to the 5th. All right, so I think out of those numbers, that's how you work Pascal's triangle. And yes, you will need to know how to come up with Pascal's triangle. All right, see you guys soon.